Okay, let's take a look at this practice quiz is very similar to the quiz that you're going to have in the following class. I know you're not here to have this quiz gone over, so let's go over it together on screen. The first question here says that you have a golfer who makes 2 shots from the tee to the green. So here's shot number 1 and here's shot number 2. And you need to find the angle that the green is from the first shot. In other words, find theta. It is not a right triangle. So the law of sines and the law of cosines should come to mind. For the law of sines, we would need to have a side length directly across from a given angle, and we don't have that. So unfortunately for us, we need to use the slightly more tedious law of cosines. So that law is that c squared equals a squared plus b squared minus 2ab cosine c, where we're going to consider this little side here to be c. So we're going to plug in the values that we have. C squared equals 217 squared plus 75 squared minus 2 times 217 times 75 times the cosine of 121 degrees. Okay. And we're just going to plow all of that into our calculator. So 217 squared plus 75 squared minus 2 times 217 times 75 times the cosine of 121. And so c squared is approximately 69478.48934, and c is the square root of all that stuff. And is a number that is approximately 263.5877261. Now, if I needed to give an answer for C, I would round there or round to 3 significant figures. But since I'm going to use that number to continue to do some working, I'm just going to keep it in that state for now. Now, in order to find theta up here, what might help is now I do have an angle and the side across from it. So I can use the law of sines. So what I can now do is say that the sine, let's see, let me switch colors. Oh, it's not letting me switch. How funny. All right, the sine of 121 degrees over this big long number c is equal to the sine of theta over 75. Because 75 is across from theta. This number here is this 263.58, blah, blah, blah. All right. Now, to find theta, first I find the sine of theta, which equals 75 times the sine of 121 divided by, again, this big long number, 263.5877261. So when I plow all that into my calculator, 75 times the sine of 121 divided by 260 divided by this big long number that I already have in my calculator, and I press enter, I get that the sine of theta is approximately 0.24389433137, and again I now do the inverse sine of this whole set of stuff, and I get that theta itself is around 14.1, and now that is correct to 3 significant figures. All right, so now let's move on to problem number 2. In problem number 2, you're asked to draw and label a diagram and then use your diagram to write an equation and solve the problem. And the question says, the angle of depression from the top of a building 60 meters high to the swing in the local playground, let's see, is 58 degrees. All right, so I don't know why it's not letting me change colors. That's so weird. All right. Okay, let's see what happens. Still red. Maybe not. All right. Anyway, we've got here the angle of depression from the top of a building 60 meters high to a swing in the local playground So here's the swing over here. And this angle of depression, which is, again, it's the angle from horizontal. So the angle of depression, this is what is 58 degrees. All right. Now, right now, and we want to know how far away the swing is from the foot of the building. We want to know this, but we don't yet have an angle inside of our triangle. We really need to get that. We need an angle in here. We need this angle. And specifically, that angle is 90 minus 58, which is 32 degrees. Okay. At this point, it should be easy for us to solve for x. We have two sides of a right triangle. We have the side that is opposite 32 degrees, and we have the side that is adjacent to 32 degrees, which brings to mind, out of the different trig ratios, out of SO, CA, TOA, we want to be using the tangent, which has the opposite and the adjacent. So the tangent of 32 degrees is equal to x over 60. Or 60 tan 32 equals x. Now I'm just going to plow that into my calculator. 60 times the tangent of 32. And I'm going to get that x is approximately 37.4921611, or 37.5 meters to 3 significant figures. Okay. Those two problems didn't seem so bad. Let's sort of move on to problem number 3. I'm going to briefly pause. All right, now let's take a look at our third problem here. I've just drawn a tiny part of it. Nina measures the angle of elevation to the top of a tree as 23.6 degrees from a point which is 250 meters from its base. So again, using my tablet tools here now, this is 250 meters from sort of, Nina to the base of the tree. All right. And it says her eye level, which is where the measurement is taken from, is 1.5 meters above the ground. So this height here is 1.5 meters. And the angle of elevation to the top of the tree is taken really from this horizontal eyeball height level. And sorry, Nina, I chose you because 1.5 meters seemed like a reasonable estimate for you. Okay, so now here's the line of sight to the tree, and this is the angle of elevation. This is 23.6 degrees. And this is 250. Well, it seems to me that if we could find this height here in orange, we could add that to 1.5 meters and find the complete height of the tree. And it seems pretty reasonable to find this orange height because we have a triangle and we have an adjacent side and we are interested in an opposite side and we have an angle measurement. So we could say that the tangent of 23.6 degrees equals h over 250, so that h is 250 times the tangent of 23.6 degrees. Let me just plow that out on my calculator. 250 tan 23.6. That's 109.22231444. And to that height, we need to add Nina's height to eyeball of 1.5 meters and get approximately 110.7223144, which to 3 significant figures is 111 meters. That is the answer to the question. It's a highly unusual and ridiculous answer to a problem about tree heights because I think the Taipei 101 is one of the tallest buildings in the world at something like 100 meters, I believe. Interesting little question to look up. Anyway, if you can do these problems well, then you should be very prepared for the quiz that you're going to have in the class that follows. Okay? that should do it.